So when we're dealing with linear equations, equations that graph a straight line, we can talk about the slope of the line. Slope is the steepness. The steepness of a line. So if you think about a sledding hill or a skiing hill, when you're skiing, if you're an advanced skier, you probably want to ski on a steep slope, one that's going to be more of a challenge. You're going to go faster versus a slope that's less steep if you're a beginner. Same thing with sledding. Sometimes you're comfortable just sledding down a mild hill, where other times you're adventurous, maybe more daring, and you want to sled down a really steep hill, has a greater slope. So in our interactive notebooks, I've taken a piece of white paper and folded it so that the two ends meet in the middle. And it just about fits perfectly in here. So what I'm going to do is halfway down, I am going to make a cut. It's okay if it's not perfect, it will work out just fine. Because when we're talking about slope, there are 4 different kinds of slope we can have. The first one is a positive slope. So if I were to sketch a coordinate plane, no numbers or anything, just the X and Y axis, a positive slope is going to go upward from left to right. It's going up. A negative slope again, I'm going to sketch a coordinate plane, an XY axis. A negative slope is going to go down. When you're going from left to right, the line goes down. There's also such thing as a zero slope. And a zero slope does not go up or down. No up, no down, straight across, horizontal line. And the last one is called undefined slope. Can you guess what it looks like? We have left to right going up, left to right goes down, horizontal. An undefined slope is a vertical line. Sometimes when I'm talking about slope, you'll hear me refer to Joe. Joe is a person, a made-up person obviously, who has a condition where he can only walk to the right. So if I were to put Joe on this line and Joe were to walk to the right, you can see Joe would be going up. So he starts on the line and he walks, he's going up. Positive slope. If Joe were to start on this line and walk to the right, which is this direction, he's going to go down. Negative slope. I'll put Joe on the line. Joe's going up, it's positive. Joe walks to the right, he's going down, it's negative. On this line, Joe is walking to the right, and he doesn't go up or down. That represents the zero slope. And then there's this one. Poor Joe. When Joe tries to walk to the right on this one, there's nowhere for him to go, and he actually falls and he breaks into a million little pieces, so he is undefined. So up positive, down negative, no up or down, 0, and when he can't even walk on the line and he falls, undefined. I'm going to tape this into my notebook right here. Now, when we talk about the steepness of a line, you should have heard this in 7th grade. Rise over run. I'm going to just go on to the left-hand side for this. I want it all on the same page. Slope can also be written as rise over run. So your slope will look like a fraction. So if I ask you to, actually I need some small coordinate planes. In your notebook, on each one of these examples, we're going to put a small coordinate plane right on the right-hand side so that we can do some examples where we're going to calculate the slope. I'm trying to use as little tape as possible so that I don't get it on my graph. These are little coordinate planes. Make sure you have your coordinate plane sitting the right way. You have your x is horizontal, your x, and then your y is vertical. Make sure you pause the video if you need more time to do this. Okay, and I'm going to close up this side because I'm going to start up here with the positive slope example. I want you to draw a line through through 5, 5, and -4, -4. We're going to draw a line through 5, 5, and -4, -4. 5, 5, -4, -4. When you are drawing lines in your notebook, try to find a straight edge. If you don't always have a ruler handy, which I don't always, you can see I'm using a pencil box. And remember, a line doesn't just stop and start at 2 points. It keeps going. It goes on forever. That's why we want to extend it past those points and put arrows on the end to show that it keeps going. Now, if I want to write this as rise over run, I need to determine how much does this line rise from one point to the other. And how much does it run? So I'm going from one point to the other, but I'm moving along the coordinate plane. And I can see that I rise 1, 2, 3, 4, 5, 6, 7, 8, 9. I rise 9, and I run 1, 2, 3, 4, 5, 6, 7, 8, 9. So our slope is 9 over 9, which can be simplified to 1. And I did forget to mention, slope is always represented by the letter m. So for this example, m equals, that was my mistake. I'll be more careful on the next one. Rise over run. We can also calculate slope by doing change in y. How much does this y change? Change in, oops, can you see that? Sorry about that. Change in y over change in x. So y is changing a certain amount of coordinates and x is changing. So we have change in y over change in x. When I go up and down, my y changes. When I go left and right, my x changes. Now, in order to find change, we subtract. So if I look at these coordinates, I have a first xy coordinate and I have a second xy coordinate. I'm going to take my y's, and I'll label these for you, x, y, x, y. I have my first set of xy, and I have my second set of xy. To find change, I'm going to take y2 minus y1, and to find my change in x, I'm going to do x2 minus x1. So if I look at this first example, y2 minus y1, my slope is going to be y2 minus y1, negative 4, oops, I did not mean to put that little line right there, minus 5, over, and I should have written that in pink because that was my rise, x2 minus x1, negative 4 minus 5. Negative 4 minus 5 is negative 9. Negative 4 minus 5 is negative 9. So my slope is 1. A negative divided by negative is a positive. So you can see either way I do it, I get a slope of 1. Let's take a look at a negative slope example. Let's start by drawing a line through, and I'll try to use coordinates this time that are not the same. So let's draw a line through. And remember, if you didn't have time to copy this, just pause the video and go back. This time we're going to draw a line through negative 2, 3, negative 2, 3, and 4, negative 3. Now, I have one coordinate here, and I have one coordinate here. This is going to be my first xy set. This is going to be my second xy set. So first, I'm going to find slope by doing rise over run. I can't calculate rise over run until I actually plot the points. So let's plot these points. Negative 2, 3, 4, negative 3. Find my straight edge. And you can see this line does go down. If I start at the left and go to the right, it goes down, so it is a negative slope. I'm going to count my rise over run. Now, we can rise and go back, or we can fall. Rising and falling, I know it doesn't sound like they're the same thing, but you will get the same thing either way you calculate it. So it looks like I go down 1, 2, 3, 4, 5, 6. And I run 1, 2, 3, 4, 5, 6. So 6 over 6. Again, that simplifies to 1, except this time I know it's a negative slope. I know that my slope is -1. When you fall, that is going to be considered negative. Falling is negative, so down 6 would be a -6. That's how you get the -1. And going to the right is positive. Now, I just want to prove to you that if I were to do that the other way, I would get the same thing. I'm going to use this graph right here to represent the same 2 points. -2, 3, 4, -3. Can really use anything as a straight edge. So instead of falling and running, I'm actually going to rise and run backwards. I'm rising 6, which if I'm rising, it's positive, and I'm going back 6. Going back 6 is also negative. So going up is positive, going down is negative. Going right is positive, going left is negative. So it doesn't matter if you fall and run to the right or if you rise and go back. This one would end up being rising 6, going back 6, which is also -1. You'll get the same thing either way. Let's calculate our slope using change. I want to do y in pink. Change in y over change in x. If you have a hard time remembering that it's y over x, remember, rise over run. Rising is a change in the y. Running is a change in the x. y2 minus y1, -3 minus 3. Oh, my color for purpose is falling to the wayside today. Sorry about that. 4 minus -2. This is where our integer rules come in so handy, because a negative minus a negative changes to a plus. -3 minus 3 is -6. 4 plus 2, 6. My slope is -1. And you should always double check yourself based on your general knowledge too. If you know this is a negative slope and you make a mistake and you come out with a positive number here, you know it has to be negative. This is a negative slope. Down from left to right, negative. For the 0 slope, let's draw a line through. Draw a line through -4, 4 and 5, 4. Here's my first XY set, X1, Y1. Here's my second XY set, X2, Y2. -4, 4, 5, 4. If I'm calculating my slope as rise over run, please excuse the interruption. Lots of announcements this afternoon. Rise over run. Do I have to rise at all to get from this point to this point? I don't. I don't go up at all. So my rise is 0. My run is 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 divided by 9 is 0. If I were to calculate my slope as a change in y, over change in x, or y2 minus y1 over x2 minus x1, y2 is 4 minus 4 over 5 minus negative 4. 5 minus negative 4. Minus a negative always becomes a positive. 4 minus 4 is 0. 5 plus 4 is 9. 0 over 9 is 0. I tend to remember this one. I think of a 0 slope like the horizon. It's a horizontal line. And when the sun's coming up over the horizon, a sun kind of looks like a 0. So that's what it makes me think of. The sun coming over the horizon is a 0. That's how I remember that that has a 0 slope. And an undefined slope. For this example, we are going to draw a line through 5, 3. Draw a line through, and we're going to do the points 5, 3 and 5, negative 3. My first xy pair, x1, y1. My second xy pair, x2, y2. 5, 3. 5, negative 3. And there's my vertical line. If I try to calculate my slope using rise over run, when I'm going from this point to this point, it looks like I'm rising 1, 2, 3, 4, 5, 6. And I'm not going left or right at all. 6 divided by 0. Now, if you've never tried to put 6 divided by 0 into the calculator, it's a good test for you. 6 divided by 0. Error. You cannot take a number and divide it by 0. I'll prove to you why it doesn't work in just a minute. This means it is undefined. And the reason why it's undefined is because usually when you have a number, 6 divided by 0 equals, I'll write undefined. Let's use an example that we know. Let's do 12 divided by 3. Well, 12 divided by 3 is 4. And that means that I can work backwards and that 4 times 3 is 12. Multiplication is the inverse of division. It's the opposite. 12 divided by 3 is 4. 4 times 3 is 12. So I want you to consider for a second what you could multiply by 0 to get 6. Because whatever this answer is, if I worked backwards and multiplied it by 0, I should get 6. Well, I know that there's no number that I can multiply by 0 and get 6. There's no way to do that. That is undefined. Nothing that I multiply by 0 will give me 6. And that's the way division works. If I divide, I should be able to do the opposite and multiply and see that it checks itself. So those are your 4 different types of slope. Positive slope, going up. Negative slope, going down. 0 slope, a horizontal line. And undefined slope, a vertical line. Slope is the steepness of a line, and there's 2 ways that we can calculate it. We can count rise over run, or we can calculate the change in y over the change in x.